In this section, we discuss web analytics. Let's start with the overview. We kick off by setting the stage. We then discuss various Clickstream data collection techniques. This is followed by a review of web metrics. We then elaborate on how to obtain actionable insights from these metrics. We conclude by discussing experiment and testing. Let's kick off by defining web analytics. It was defined by the Web Analytics Association, or WAA, already in 2011 as web analytics is the measurement, collection, analysis, and reporting of Internet data for the purposes of understanding and optimizing web usage. In his 2004 book, Web Analytics Demystified, Eric Peterson defined web analytics as web analytics is the assessment of a variety of data, including web traffic, web-based transactions, web server performance, usability studies, user-submitted information such as surveys, and related sources to help create a generalized understanding of the visitor experience online. 2 points are worth noting from both definitions. First, web analytics analyzes a variety of different types of data. Secondly, the ultimate goal is to facilitate and optimize the visitor experience online. Note that the terms web analytics and web mining are often used interchangeably. 3 different types of web analytics can be distinguished. The purpose of web usage mining is to discover interesting patterns in how visitors use a website. An example could be a sequence of pages that is frequently visited. Knowing this could help improve website design and help visitors more easily find their way through your website. Web content mining tries to extract useful information or knowledge from web page contents. Actually, this is very closely related to text analytics. For example, Google is doing this to help them understand the content and purpose of a website and how to include it in their search results. Web structure mining tries to mine the hyperlink structure of the web. This allows to find groups or communities of websites discussing similar topics. Web analytics can serve different goals. First of all, it could help in improving your website design. This could be based on analyses to study how customers or segments of customers navigate through your website and whether they find what they are looking for. Also interesting is to find out where customers leave your website and whether they were happy with your website experience. Another interesting goal could be to measure the effectiveness of your search engine marketing or SEM activities. Remember, 2 basic types of search engine marketing are search engine optimization or SEO, which aims at ranking high in the Google search results in a spontaneous or organic way without having to pay for it, and pay-per-click or PPC, where you pay a search engine such as Google to rank at the top of the search results for carefully chosen keywords, whereby payments are only needed when someone clicks on your ad. Using web analytics, we can also monitor the effect of a strategy such as a promotion on your web traffic and conversion rates. It can also be used to measure the effect of banner or email campaigns and search engine visibility. Web analytics allows us to optimize the design of your landing page. Remember, the landing page is the first page a user sees when he or she visits your website. We can now design variations thereof and using web analytics test differences in conversion. In what follows, we discuss 3 different types of Clickstream data collection techniques: server log analysis, cookies, and page tagging. Server log analysis is the first way of gathering data for web analytics. As the term suggests, the data is captured at the server side. Every HTTP request for a resource produces an entry in a web server log file, which you can think of as a huge text file. This web server log file can then be parsed and processed to provide the useful web analytics information. Let's get into some more detail. Here you can see an example entry in a web server log according to the combined log format as used by Apache and NCSA. It starts with the remote host IP address or domain name. Note that this can help identify the location of the client computer and thus provide useful information about what geographical regions we attract visitors from. This is followed by the remote log name and username. Both are usually empty, as represented by the dash symbols in case no authentication has been provided. Then we have the date and time and an offset from the Greenwich Mean Time or GMT. This is useful to see when we have peak moments on our website. This is followed by the HTTP request method, which can be, for example, GET or POST. Next, we have the resource requested relative to the root directory location on the web server. This could also include query string parameters after the question mark symbol, as illustrated at the bottom of my slide. A following entry indicates the HTTP version, which is 1.1 in our case. Next, we have the HTTP status code, which is in our case 200. The 200 range represents a successful request, the 300 range a redirect, the 400 range a client error such as 404, which means page not found, and the 500 range a server error. Finding and correcting the 404 error requests in the web server log is very important, as visitors quickly get annoyed if they don't find the information they are looking for. The number of bytes transferred is also included. The next piece of information is the referrer. In fact, this represents the web page which the user was on before and where he or she clicked on a link to arrive at your site. In the case this would have been a search engine such as Google, also the query string is sent along. This query string is actually very important for search engine marketing purposes, as it exactly tells us what Google search terms connect to our website. If, for example, we see that the search terms buy wine frequently link to our website, then we shouldn't pay Google for these search terms using a sponsored ad campaign, as we already get the traffic anyway. Next, we have the user agent, which consists of the browser and platform that the client is using. This is also useful as it tells us what are the most popular browsers and platforms used to visit our site, so we better make sure our site performs well on these. Note that this could also be a search bot, which is a type of software program that automatically crawls the internet to determine the content of websites such that search engines can decide where to include your website in their search results. The Google bot is doing this for Google. Finally, also cookie information can be included, as we discussed later. Cookies have become an essential part of our web browsing experience and a very important web analytics data collection mechanism. Essentially, a cookie is a small text string that a web server can send to a visitor's web browser as part of its HTTP response. The visitor's browser then stores this cookie on the hard disk as a small text file. The browser will send back this cookie unchanged to the web server each time a new request is sent to it, such as when the visitor visits another page of the site. The cookie typically contains a unique user ID and other customized data, such as the domain and path from where it can be read and an expiration date which is optional. You can see an example of a cookie at the bottom of my slide. Cookies can be set and read by and their contents shared between client-side as well as server-side scripts. A web server cannot retrieve cookies from other sites unless by exploiting vulnerabilities, a malicious practice sometimes referred to as cookie stealing. Cookies can be used for various purposes, such as implementing virtual shopping carts, remembering user details, or providing a customized user experience without having to log in each time. They also facilitate easier gathering of information about the site's visitors, which will come in handy for session identification and detecting return visitors, as we discussed later. Finally, they can be used for banner ad tracking, which we also cover in what follows. Various types of cookies exist. The first distinction is between session or transient cookies versus persistent cookies. A session cookie is only used to keep state information for the duration of a visit or session. It will automatically disappear after you close the visit or session or browser. A persistent cookie is saved to a file and kept after the end of the session until a specified expiration date. When the user returns to the site, the web server will retrieve the persistent cookie and thus be able to identify the user as a return visitor. Another distinction is between first-party and third-party cookies. First-party cookies are set from the same domain that hosts the web page you are visiting. A third-party cookie is set by a web server from another domain. This could be an ad network serving banner ads on the site you are visiting. You can see the difference between first-party and third-party cookies illustrated here. Suppose you visit website 1, a travel website where you were looking for booking a trip to Sydney in Australia. Website 1 requests to load an ad from an external third-party server. The latter could be an ad network specialized at offering tailored ads to visitors, typically based upon their browsing experience. A popular example of an ad network is Google AdSense. This ad network then returns the ad and sets a cookie at the same time. By now, this third-party server knows you are interested in traveling to Sydney. A few days later, you visit another website, say your Facebook page. Again, an ad is requested from the same third-party server and the third-party cookie set earlier is sent along. Since the third-party server now recognizes you based on the cookie, it knows you are interested in traveling to Sydney. And you can now see ads appearing on your Facebook page with good deals for flights to Sydney or hotels in Sydney. This is how third-party cookies work. Hence, third-party cookies can be used to count impressions or the number of times an ad was served, but also to track visitors across different sites. As illustrated before, they can be used for behavioral targeting by bringing up ads based on websites the same user visited earlier. However, there are also some difficulties when working with third-party cookies. First, browser privacy settings or anti-spyware software might prevent third-party cookies from being set or kept. First-party cookies are typically erased less often by users because they are deemed less intrusive, and the deletion affects the browsing experience, such as settings that are forgotten, the need to log in each time, etc. Finally, there's obviously also the privacy aspect, since a third-party you are unaware of is collecting your data. A zombie cookie is a cookie that is recreated after deletion. It is recreated from backups stored outside the web browser's dedicated cookie storage area. It usually exploits a breach of browser security and can track users across browsers on the same machine. It is highly denounced by privacy advocates and has been the subject of various lawsuits. EverCookie is an example of an open source JavaScript-based application which produces zombie cookies. As opposed to web server log analysis, page tagging is a web analytics data collection method where data is captured at the client side. The idea here is to tag every web page of your website with a code snippet referencing a separate JavaScript file that deposits or reads a cookie and then sends data about the visit to the data collection server. A very popular example of this is Google Analytics. To implement page tagging for Google Analytics, one should copy and paste the code at the bottom before the closing head tag of each HTML page you want to track. The string highlighted in red represents the tracking idea and tells Google Analytics which account to send the data to. You can see that the code basically loads the analytics.js library, which is a JavaScript library for measuring how users interact with your website. When you add a page tag to your website, various information is collected, such as page views, the time spent on the site, the time spent on each page and the sequence, the internal links clicked, the IP address, and based on this, the geographical location, the user agent or browser and operating system, and the referring site. When using page tagging, it is often wise to make use of an analytics vendor that provides a hosted service rather than purchasing, setting up, and running the web analytics page tagging solution yourself. The idea here is that the data storage and processing takes place on the vendor's servers. The client is then provided with a web interface to access reports or run analyses. When compared to web server log analysis, page tagging offers various advantages. First, it breaks through proxy servers and browser caching. In case of web server log analysis, if a page is cached, no record is logged on the web server, which creates inaccuracies in the data collection. Page tagging allows to track client-side events, which is not supported by web server log analysis. Page tagging supports easy client-side collection of additional data, for example by defining custom tags on an order confirmation page. This is not that easy for web server log analysis, since integration with another database is required. Page tagging facilitates real-time data collection and processing, whereas log files are typically analyzed in batch. Page tagging is often supported through hosted services, which offers potential cost advantages. Furthermore, when using page tagging, the data capture is separated from the web design or programming. In other words, the JavaScript code for data collection can largely be updated by in-house analysts or the analytics service provider without the IT department having to implement changes. In case of web server log analysis, there is a large reliance on the IT department to implement changes to capture more data. And finally, there are more innovation efforts put in by web analytics vendors, which is not the case for web server log analysis. Page tagging also comes with some disadvantages. First of all, not including the correct tags will give runtime errors, which means the data is lost. This is not the case in web server log analysis, since the historical data remains available for processing. Firewalls and browser privacy or security settings can hinder data collection. In server log analysis, the server-side data is collected regardless of the client configuration. Page tagging cannot track search engine bots, since bots typically do not execute page tags. This is not the case in web server log analysis. With page tagging, it is less straightforward to capture technical information, such as error, bandwidth, download time, etc. Web server log analysis is designed to automatically capture technical information. When using a hosted solution for page tagging, you face a loss of control, which is typically not the case for web server log analysis, since the data is usually analyzed in-house. In what follows, we discuss the following web metrics: page views, visits and sessionization, unique visitors, types of visitors, time on site, bounce rate, referrers, and conversion metrics. Page views is a first web metric. It represents the number of times a web page has been viewed. It is a key building block for many other web metrics, but not that meaningful on its own. There could be various reasons why your page views are up. It could be because customers are engaging more with your site, you are attracting more visitors, or because your visitors cannot find the page or information they are looking for, which is obviously not desirable. Your key goal should be: have visitors met their objective after having viewed the page or not? The next step is to identify visits or sessions and do sessionization. Note that we consider the term visit and session as synonyms. A web visit usually consists of a sequence of web pages. An example is illustrated. The user enters to the home page, index.html, then visits products.html, followed by reviews.html, and exit. Sessionization is a procedure that is used to determine which page views are part of the same visit. Note that web analytics vendors typically use proprietary sessionization procedures, which makes it nearly impossible to compare metrics between different web analytics software. Visitors can be tracked by means of IP address, and user agents, cookies, URI parameters, or a combination of all of these. Let's elaborate a bit further on this. Sessionization based upon IP address alone is not very reliable, since visitors might get the same IP address for different computers behind the same router or firewall. Think about employees logged into a company network or members of the same household sharing a router at home or using the same ISP or Internet Service Provider proxy server. Furthermore, most home users get issued IP addresses dynamically out of a pool of IP addresses by their Internet Service Provider. Moreover, some Internet Service Providers use web proxies that can even change IP address for each request. So using the IP address alone for sessionization is not sufficient. The combination of IP address and user agent is already better, but still not unique since many visitors use the same browser and platform. You can see an example of a user agent string on my slide. A better alternative is to make use of explicit session identifiers, which are typically held in transient cookies. These are then passed along as URI parameters as you navigate through the site. Web analytics vendors often allow a combination of these methods that can then be further configured. Additional heuristics are also used to make the sessionization as good as possible. The first one is referrer data. If a page cannot be reached from the previous page in the session, then a new session should be defined. Also, session timeouts are typically used. If the period of inactivity exceeds a predefined threshold, then a new session is defined. A commonly used number here is 30 minutes. Finally, we can also impose a maximum for the total session duration. After having identified visits, a next step is to identify and count unique visitors. This always pertains to a given time period. More specifically, if a visitor visits our site twice or more within a given time period, then we should not count him or her twice. Another point worth mentioning is the well-known hotel problem, stating that the number of unique visitors for each day in a specific period of time does not add up to the total unique visitors reported for an entire period of time, say a month for example, since the same visitor can visit the site on different days of the month and should thus not be double counted when looking at monthly statistics. A key problem is how to identify a repeat visitor. Using the IP address is not feasible since this may change in time. Another option is to use persistent cookies, but this is also not fault-proof. When using cookies for identifying repeat visitors, you're actually counting browsers, not visitors. People often share computers, own or have access to multiple computers, and might even use different browsers. Finally, cookies may get blocked or erased, which further complicates the matter. Here you can see some recommendations listed for identifying unique visitors. The most important cookies should be first-party cookies. You can also easily measure cookie rejection rates. This can be done by writing a cookie and reading it back immediately afterwards. This method allows to calculate average cookie rejection rates. Another recommended practice is to consider a site registration or login method, or make it worthwhile for visitors to keep cookies. If keeping cookies can help realize time savings, such that visitors don't have to log in each time, or help them in providing personalized content, then visitors might be more tempted to keep cookies. Given all these considerations, I think it's clear by now that the data collected using web analytics is imperfect and metrics such as unique visitors will never be perfectly calculated. Hence, when assuming the imperfections such as cookie rejection behavior remains constant, it is recommended to not look at absolute values but at trends instead. Different types of visitors can be distinguished now. New visitors are unique visitors with the first ever visit during the reporting period. Repeat visitors are unique visitors that visit your site multiple times during the reporting period. Return visitors are unique visitors who also visited your site prior to the reporting period. The distinction between these different types of visitors is useful for determining site loyalty and affinity of visitors, but also for analyzing differences in site usage between new, repeat, and return visitors. You can see this illustrated here. For reporting period 1, we have 3 unique visitors, A, B, and C. We have 2 repeat visitors, A and B, and we have 2 new visitors, B and C, and we have 1 return visitor, A. For reporting period 2, we have 4 unique visitors, A, C, D, and E. We have 2 repeat visitors, C and D, 1 new visitor, E, and 3 return visitors, A, D, and C. For the combined period 1 and 2, we have 5 unique visitors, A, B, C, D, and E. 4 repeat visitors, A, B, C, and D, 3 new visitors, B, C, and E, and 2 return visitors, A and D. Note that as you can see, you cannot add up the numbers for period 1 and 2 to obtain the period 1 plus period 2 numbers. Time on site or visit duration is another interesting web metric. However, it is not that straightforward to measure. Consider the following sequence of page views: page 1 at 1 p.m., page 2 at 2 minutes after 1 p.m., and page 3 at 5 minutes after 1 p.m. This is followed by the visitor exiting the site. We know the visitor spent 2 minutes on page 1 and 3 minutes on page 2, but we don't know how long the visitor spent on the last page. By calculating the time on site as 5 minutes, we assume the time on the last page to be 0, which is commonly done. Hence, the time on site metric is often an underestimate of the actual number. To summarize, the time on site metric is typically calculated as the timestamp of the last recorded activity minus the timestamp of the first activity in the session. A couple of things are worth adding. In many cases, the visit only concerns a single page. Think about checking the headlines of the news, for example. Obviously, the time on site metric becomes meaningless then, since it cannot be calculated. One should also be careful when applying the time on site metric. Sometimes you want this metric to be high, sometimes you want it to be low. For example, a support site wants to solve the problem quickly and aims for a short time on site so as to avoid phone calls to your service desk. However, a content site might want to get users engaged and aim for a longer time on site. The bounce rate is a very important web metric. It is the ratio of the visits where the visitor left instantly. It can be measured both at site or page level. The bounce rate of the site is the ratio of single page view visits or bounces over the total number of visits. The bounce rate of a specific page is the single page view visits of that page over the number of visits where that page was the entry page. Note that when calculating bounce rates, it is wise to decide to leave out redirected and/or error pages. Various alternative definitions have been proposed. Instead of single page views, we could also take as numerators single page visits where a page refresh still counts as a bounce, or the percentage of visits where the time on the site is shorter than, for example, 5 or 10 seconds, or in case of single page applications, we look at those visits where there was no user interaction or tracked event. Note that the bounce rate is not the same as the page exit rate. This is the number of exits of a page divided by the total page views of that page. You can see this illustrated here. Suppose we have 8 visits. Visit 1 consists of pages A, E, and B, and so on. The bounce rate of the site is 5 divided by 8, since visits 2, 4, 5, 7, and 8 represent bounces. To calculate the bounce rate for page B, we look at those visits where page B was the entry page. These are visits 2, 3, 5, and 7. In 3 of those cases, the visitor left immediately afterwards, giving us a bounce rate for page B of 3 divided by 4. Let's now also calculate the page exit rate for page B. Page B was visited in visits 1, 2, 3, 5, 6, and 7. In 5 of those cases, the visitor left after having seen page B, so resulting in a page exit rate of 5 divided by 6. The bounce rate is actually a very actionable web metric. To further study it, You can segment it in various ways. The first way is by traffic source or referral page. This allows you to identify what sources are sending you bad traffic or traffic with high bounce rates. We can also segment it by search engine to see if your website is appropriately indexed by the popular search engines such as Google, Baidu, Yahoo, etc. We can also segment it by considering our most popular top landing pages. Another option is by country or other geographical region. Referrer information is also very interesting information to know when your visitors come from. This can be inferred by means of the referring URI and search keywords in case of search engine traffic. Remember that if a user enters search terms in Google that link to your site, these are being sent along in the URI, so this is very interesting information. Knowing your popular referrers is interesting for optimizing your acquisition strategies, creating personalized experiences, or A/B or multivariate testing, as we discussed later. Do note, however, that your referrers are not always known. Since the website was bookmarked, the URI was typed directly in the browser, the traffic comes from an email marketing campaign, or the visitor's browser has hyper-secure security settings. It is also recommended practice to apply segmentation of other web metrics, such as time on site or bounce rates, based on referrer information. You can then find out which referrers are sending you good traffic and which ones are sending you bad traffic. A conversion is defined as a visitor performing an action that is specified as a useful or desired outcome, considering the website's purpose. Examples could be a product or service purchase, clicking on an ad, downloading a PDF, a newsletter sign up, or sending a request for further information. The conversion chain then represents the sequence of conversion steps, such as clicking on an ad, configuring a product or service, starting a checkout process, and ending with the actual payment. The counting unit can be the number of times a conversion occurred, the number of visits during which a conversion occurred, or the number of unique visitors that converted. Note that when calculating these, it is also important to indicate the time frame of the count. Here you can see some examples of conversion metrics. What percentage of visits includes an online purchase? This is in fact an easy way to track the effectiveness of ad campaigns or test the effectiveness of alternative page designs. What percentage of unique visitors converted into an online purchase in a given time period? Obviously, this relies on an accurate unique visitor measurement, which is not that straightforward as we already mentioned. These conversion metrics can then also be further segmented. For example, we can segment the conversion rate by the top 5 referring URIs or by traffic type or acquisition source. It is also very important to look at trends and changes over time. However, conversion rates should not be interpreted in an absolute way. It is important to also combine it with other outcome data. For example, conversions could be up because of discounts and not because of website improvements or better quality of the traffic source. Hence, it is advised to also consider the sales price, total revenue, and return on investment or ROI. The key message is to not overly focus on conversion rate, but interpret it wisely. Also note that people might visit your website for research about products or services and then buy offline, or to get help or support, apply for a job, or check their order status. In what follows, we discuss how to move from metrics to actionable insights. More specifically, we discuss monitoring and trend analysis, dashboards, segmentation, site search reports, and navigation analysis. First step to turn web metrics into actionable insights is by using monitoring and trend analysis. Companies doing web analytics continuously monitor the reports on their key web metrics. In fact, this is also what I'm doing myself on my own websites to better understand what visitors are interested in and where they come from. Companies compare their web metrics against previous time periods and see whether there are any changes. Examples could be popular referrers disappearing, new referrers, the top 5 referrers that has changed, the top destinations that have changed, etc. All of this should then be followed by the question, why? Metrics should also be monitored over time periods. Do we spot any anomalies that we can learn from? Is a metric up or down unexpectedly on a certain day, and what happens that might explain this? A new competitor who entered your market, a competitor that went out of business, a new product or service introduced by yourself or a competitor, or maybe even just seasonal effects. Do we see an upward or downward trend in metrics? Are these desirable and why are they happening? Do note that comparing a metric against a previous time period only can be misleading. This could be due to cyclicality, such as seasonality. Think about the Christmas shopping season or Black Friday, or simply weekly patterns. Some solutions to these problems are: inspect the visual plot of your metrics over a long enough period of time to filter out temporary effects. Include observations from the same time period last year, or estimate a statistical time series model such as an ARIMA or GARCH model to properly understand what's happening. To summarize, looking at trends is very important. First of all, because web analytics always starts from imperfect data. Think about cookie deletion, for example. Also note that many web analytics vendors use proprietary definitions for visitors, sessions, bounce rates, etc. To effectively monitor and communicate critical business performance information, dashboards are used to monitor your web metrics. A dashboard provides a concise, easy to understand visual display showing key performance indicators or KPIs, possibly set against a target or benchmark, or real-time or periodic snapshots. Dashboards often provide intuitive indicators such as gauges, stoplights, and alerts. They can be personalized according to the user's wishes, provide links for further analyses, and often run in a web browser. Here you can see an example of a Google Analytics dashboard for my Blue Courses website. This is a course business providing online courses which I run my own. The courses are on big data and analytics related topics. You can see the evolution of users during the month of February 2020. You can see that we had a total number of users of 1,861, of which 1,563 new users. We had 3,210 sessions with an average of 4 pages per session. The pie chart shows the distribution of new and return visitors. To the left, you could see a navigation panel which allows to create customized report. Here you can see an example of this, where we looked at the geographical distribution of our visitors. You can see that many visitors come from the US or India. You can also see that we have a pretty good worldwide coverage of our visitors. Segmentation is a very important activity during web analytics. The idea is to take any web metric of interest, think about conversion rate, bounce rate, or time on site, for example. We then break down this metric across various segments of interest and compute aggregate measures such as totals, proportions, etc. Per segment. As an example, we can segment our web metric by traffic source such as Google or not, acquisition strategy such as direct marketing, PPC, pay-per-click, SEO, search engine optimization or organic search, email, marketing, newsletter, affiliates, etc., geographical region, or the top 5 referring URIs. Site search reports are a very valuable source of data for analyzing in web analytics. The goal is to understand the usage of the internal search engine. This is a basic form of market research, as your users tell you exactly what they are looking for. Interesting reports could be on the search terms used, at what page the search box is used, what page a user goes to following the search, whether further search refinements are done, whether they are more likely to convert, whether their average order value is higher. After you know these internal search keywords, you can include them in your paid and organic campaigns, as well as to ensure that your landing pages are optimized for them. Some further interesting information is site search usage. How frequently is the search function used? What keywords are used most? Also, site search quality is interesting to evaluate. We can calculate the bounce rate for site search, such as the percentage of search exits. We can also do segmentation, such as, do new visitors search more than returning visitors, or is there a difference between visitors coming from Google or other search engines, such as Yahoo? The idea of navigation analysis is to understand how users navigate through your website and whether they can easily find what they are looking for. A first way of doing navigation analysis is path analysis, which is based on the analysis of frequent navigation paths. The key question to be answered here is, from a given web page, which other pages do users or groups of users visit next in X% of the times? We obviously hereby assume that the users follow a linear path, which is not always the case since the user may go back or forward, have different tabs open, etc. Here you can see path analysis illustrated in Google Analytics. In the red rectangle, you can see the About page of My Blue Courses Basic Credit Risk Modeling course. Below, you can see how many people directly entered through that page, about 32%, and how many were on a previous page before, about 68%. You can also see how many exited after having seen that page, around 40%, and how many went on to another page, about 60%. In a table below to the left, you can see the pages people viewed before the page we are analyzing, and to the right, the next page in their path. You can click on any page you see in the report, on the left or right, to then analyze that page. The report will automatically update. You also have the option to click on the name of the page you're currently analyzing in the red rectangle and then search for another page. Here you can see another example of path analysis in Google Analytics. It is called a users flow report and is a graphical representation of the paths users followed through your site, from the source through the various pages, and where along their paths they exited your site. At the top left, you can see that we are interested in looking at differences between navigation paths of visitors from different countries. You can easily use other criteria such as acquisition channel, new versus return visitor, marketing campaign, type of browser, etc. In this report, you see nodes which represent pages and connections which represent navigating from one page to another. The sizes of the nodes and connections are proportional to the number of visitors. The red colored parts represent leakage or visitors dropping out after having seen that page. The report is interactive, allowing you to highlight different navigation paths to see the flow for those sections without losing sight of the overall navigation picture. Another way of doing navigation analysis is funnel analysis. The idea of funnel analysis is to define a predetermined sequence of pages and then measure entry and exit at each stage. The end stage of the funnel usually represents a conversion, such as a purchase, collected lead, etc. In other words, funnel analysis is a method of understanding the steps required to reach a conversion on your website and how many users get through each of the previous steps. The set of steps is referred to as a funnel because the typical shape visualizing the flow of users is similar to a funnel which you use in your kitchen. Funnels can be defined for different time horizons, such as for one visit or across several visits spread in time. The latter obviously assumes identification of users across sessions using, for example, persistent cookies. You can see an example of a funnel which I took from the website below. It concerns a website selling personalized bike tours, and a conversion is defined as a collected bike tour lead. The first step is selecting a bike tour from the tour catalog. To the left of the first step in this funnel, you can see the entrance or referral pages. To the right, you can see the exit pages. You can see that out of the 56 that visited your tour catalog, 2,746 moved on to the next stage in the funnel, which is the tour description. We do have quite a bit of leakage after this first step, so the tour catalog page may be ready for optimization. Do note that since step 1 of the funnel was defined as required, we do not have entries that occur at lower steps. From the tour description page, you can see how many move on to the inquiry form page, and from there onwards to the bike tour lead page, which represents a conversion. You can see that 2,273 visitors converted, which represents a 44.96% funnel conversion rate. Given all the knowledge we have acquired in the previous sections, we can now start with experimenting and testing with web page design. This is actually the fun part of web analytics. The idea is to set up an experiment whereby we present different pages or page elements to random samples of visitors. For each page variant, we then statistically compare a metric of interest, such as the conversion rate, bounce rate, time on site, etc., and see whether it is better for one page design than another. Various pages could be considered, but some obvious choices are the landing page, or the page you land on after you clicked on an ad, a page in the checkout process, the most popular pages, or the pages with high bounce rates. Two types of testing can be considered: A/B testing and multivariate testing. We elaborate on both in what follows. The idea of A/B testing is to test one or more alternative versions of a web page on a random sample of visitors and compare their behavior in terms of, for example, conversion or bounce rate against a control group of visitors who get the original page. You can see this illustrated in the figure. 50% of the visitors get the original page, 25% version A and 25% version B. You can also see that version B gets the highest conversion rate. It remains to be tested, however, if this is statistically significantly different from the other conversion rates. Here you can see an example of A/B testing which I took from the website below. Electronic Arts, a successful media company, relied on A/B testing when releasing SimCity 5, a simulation game that allows players to construct and run their own cities. Most marketeers assume that giving an incentive will boost sales, as you can see illustrated in the version to the left, which offers 20% off a future purchase. The version to the right was without this incentive. As it turned out, the right variation performed more than 40% better than the left one. Avid fans of SimCity 5 just wanted to buy the game and weren't interested in the incentive since they don't play any other games. These are typical insights you can gain via A/B testing. Finally, the idea of multivariate testing is to test more than one element on a page at the same time. Suppose we have an online movie rental store and we need to decide on our homepage. We experiment with two choices for the headline: unlimited movies or cheap movies. This is variable x1. Variable x2 is the sales copy, and say we want to choose between three movies. Variable x3 is an image or our hero shot, and we want to choose between a male and female actor. Variable x4 is the button text, and here we choose between either try it now or discover. Multivariate testing will now try all of these, or a careful selection thereof, and also see whether there are any interactions.